All right, guys, part 2 on refrigerant leak checking with Tyler Nelson from Sauermann. And again, I hope you guys pick something up. I hope you learned something here. And it's really a deep dive, open-ended conversation. So let's get to it, guys. This is the HVAC Know-It-All podcast. I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. So I've been working a lot with Spectroline, the Spectronics Corporation, and I've just had many conversations with them over the last year. Copeland, probably arguably one of the biggest compressor manufacturers in the world, allows Spectroline dye in their systems. They tested it, and it's an actual, there's a bulletin, I don't remember the bulletin's number, but it's an actual approved lubricant in their approved additives to the system.
Yeah.
So that's a lot of weight right there. There might be some dyes out there that are not manufactured the same way and could cause issues in a system. I haven't tested those. I haven't talked to people about those. I don't know. All I know is that I've used Spectroline lots in my career. I mean, I went back to a post when I first started, because somebody's like, "Oh yeah, like you're gonna throw that in the system now," and blah blah blah. I said, "Dude, I've thrown this in the system in like 2012," and I went back to a post. 2012, I went back to a post where I had gone back to that system and showed the tag, and it was 2012. I put it in, and this was a Liebert again in a data center, and compressor's still running fine, no issues whatsoever. So if you use the right one, again, Spectroline is a highly filtered lubricant, and I don't know how they get it to glow, but they've obviously done something to do that. But it is an oil; it's a lubricant.
Yeah, their stuff is excellent. I'm partial to their stuff because I've spoken to some of the people that work there. I know how effective it is, and some of my reps actually rep it for Spectronics, and their stuff is tremendous, and it won't interact negatively with the components of a system. You know that there's others out there that cause an issue that can clog up a system overall, and that's an issue. And we had that in the past where it didn't work, or if it did, it worked temporarily until it clogged something else down the line, and then we got a little bit jammed up for the product that we had selected at that time to use. But now with, as you said, with Spectronics and with it being authorized for certain manufacturers, that just tells you something, because they're not going to play games with what they're working with. They're going to, if they're able to make their recommendation, that they're taking it very seriously.
Yeah, and it can also, in a way, so I've made a bit of a prediction saying that I think manufacturers sooner than later are going to start potentially putting dye into the systems from day one to make it easier, because there's a lot of, I talk to a lot of people that are very frustrated with the amount of leaking evaporator coils in the industry and how it's killing their profit, their margins, because now they're out on warranty calls all the time and taking guys off the road to go do actual money-making service calls. So I've come to the conclusion that I think manufacturers might actually start putting dye into systems from day one, so they're easier to find, quicker to find, because it becomes a proactive leak searching method at that point. You just got to go to the system. If you know the dye's in there, you grab your black light and you shine it all over the unit, maybe take 10-15 minutes, and there's the leak and you're done, right? Yeah. Rather than going through the whole search method from start to finish. I mean, it's just a thought of mine. I'm not sure if it's going to come to fruition, but
yeah, it's an interesting thought. And I think if we see it, you're going to see it with those more high-end manufacturers of equipment on their high-end stuff, where they know it's not going to leak, but they're going to let you know from a safety assurity standpoint that it's in there. So if there ever was a refrigerant leak, the mechanic who works on your system can find a leak all that much faster. So there's the moment we say it's not going to happen, Gary, is the moment it does. So yeah, I'm open to any possibilities with this industry, because we've seen it evolve so many times over the years that it's innumerable. You can't count how many iterations there's been to things and how much we've evolved as a practice with certain things.
Yeah, well, NDL has a dryer already that's got a dye pack in it, a dye wafer in it. So you put the dryer into the system, it slowly releases the dye in. Okay, so you mentioned leak sealants earlier. Leak sealants is another one that is hard for people to accept. Now, back in the day, leak sealers used to come in a can, and you had to actually put the hose on, pull a vacuum on the hose, because you couldn't let that, whatever was in that can, you couldn't let it touch air or moisture because it would like start to harden. Nowadays, leak sealants are made differently. They're more oil based now, so they actually come in like clear inject like plastic injectors that don't have to, you don't have to pull a vacuum on or nothing, because they don't harden. They work a little bit differently. Give me your initial take on leak sealers.
It's, I'm not a big fan of them. I, because of the clogging that they can cause, and some of them have a grainy nature to them. They can cause an issue into a system. It completely screws up the whole refrigerant reclaim side of things as well. So we got to think down the line what's going to happen to a system. I prefer, I've used them where there's been no other option. That when you talk about working on these levered systems and everything else, say if you're working in a medical facility, they need it to run, and you don't have time to get a part for them or whatever. You don't have time to do a further inspection or fix a leak or figure out where it's at, and you're going to put a leak sealant in there. Those are applicable times, but more so than not, it's a challenge, and the ramifications of using it, if it works at all, but the ramifications of using it can be serious down the line. And also that material in there can also wear away inside of there, and that leak can show up again. It all depends on the situation, but a lot of those times too, what that material is made of can have a negative reaction to what those components are made of, and the copper and everything else, and even those brazing joints and everything else. It can have a negative reaction with what's in that system, as you know.
So I've went down the rabbit hole with one particular leak sealant, and it's been about 8 years now of testing. Everybody knows that follows me that which one it is, because it's on the top of the podcast, AC Smart Seal. So it was given to me probably about 8 years ago, and they said, "Hey, can you work with this? Can you test it?" And originally I said, "No, I'm not doing it, because all leak sealers are bad. They're just going to clog up." And I was very like some of these guys on Facebook that I don't like their comments. I was like that. And I'm like, maybe I should be a little bit more open-minded and start actually testing to see if what they say is true rather than dismissing. So they sent me a bunch, and I put it in refrigeration systems, data room center systems, rooftops, all kinds of things. No negative ill effects on the system whatsoever. Zero clogging going on, because it's not a formula when it hits air or moisture that hardens. It doesn't work that way. It works a little bit differently. I've used it in systems where the leak was too big and it didn't work. I've used it in systems where the leak was just right and it did. The one I was telling you about in 2012, where I put UV dye in a system, the unit right beside that, this is going back about 4 years ago, maybe 5 years ago, the evaporator coil was leaking. I put my refrigerant leak detector, and it's going beep, 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 pulled it away, beep, 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 same spot every time. So I'm like, you know what? They need a new unit anyway, because the evaporator is starting to leak. So I put it in, the leak sealer and the smart seal, and I put two things of it in, because one wasn't enough, in my opinion. And I went back a couple weeks later, and leak detector in the same spot, nothing, zero, right? Because the leak was small enough. A few years later, the unit's still running. Nothing is going on with it whatsoever. So my take on leak sealants began to change as I actually put the time and effort into testing and actually using them in the right circumstances, like out of warranty machines, formicary corrosion on the evaporator. Because listen, people say to me all the time when I posted about it, they're like, just fix the leak. And I'm like, dude, it's formicary evaporator corrosion. The only way to fix it is to replace the evaporator. I don't have one in my truck today, and I want to get them going. I'll replace
You have
it.
to limp them along. Yeah.
I'll replace it after the fact. And the other thing, in Canada here, technically we're not allowed to put refrigerant into a system until we've sorted the leak situation out. So there's nothing in the rules that states that we can't put one of those in and then charge it. There's nothing stated along those lines as we speak. So that is how I sort of work around that issue. Sometimes it works, sometimes it doesn't. The leak has to be small enough. My rule of thumb is if it loses 15% of its charge annually on a small system, then there's a good chance it may work for you.
Yeah. It's not a one size fits all scenario. It's not the perfect fix all the time. So as you just described, it's situation contingent, and especially with the form of carry corrosion. And if you have to limp something along because someone needs their system to work, because it's in a medical facility or if it's in a server room, you don't have a choice. You could say fix a leak all day, but if you can't get it fixed, and you don't have it, or you need a new coil, or it's out of warranty, or whatever, and someone needs to limp it along from a financial resource perspective, it's what you need to do. But again, it's not the perfect scenario. So I'm less than 50-50 with it, but I'm willing to have my mind changed, especially as I get on in years and learn more about this trade. And as you just gave that instance there where that you found one that you like, and that's been reliable for you. What is your level of confidence with, I know it's situational contingent, but if you were to weigh it on a scale of 1 to 10, as far as how confident you are that it would work for most techs, what is your level? 10 being the most confident.
If like I said, if the leak for that particular one, I can't speak about others because I haven't done that full on testing. I'm not opposed to testing other ones either on out of warranty units with leaking coils and stuff like that. I'm not opposed to it because that's who I am now. I don't say no to things. I don't dismiss. I test. I don't know, somebody said it. You don't know until you test, right? Or if you're not testing, you're guessing.
Yep.
So that's a tough one to be honest on a scale of 1 to 10. My advice would be if you come across a unit, you do run your leak detector over a coil and it's sending you signals. Hey, we got a leak here. You're not taking that coil out and fixing it, because here's the thing. If it's already to the point where there's form of carry corrosion, it's weak. If you're trying to cut away the fins to fix that one spot, you're going to damage other parts of the coil. At that point, it's labor intensive. Who's going to pay for you to recover the refrigerant, pull it out, try to fix it, put it back in, pressurize? You know what I mean? It's not something that someone should be paying for. So if you get to that point, there's no harm in trying it out and putting it in and saying, okay, you're probably going to need a new system anyway, because unless the evaporator is under warranty or something like that, it's a couple years old. But here's the thing. There's 2 companies in Florida about 5 years ago put it out publicly that they were putting sealant into systems because they were tired of warranty evaporator calls. They were sick and tired of it, and they put it in from the beginning, right from the beginning. So 1 to 10, that's a difficult one for me. It's got to be a situation where it's like evaporator form of carry corrosion. You got to get the customer back up and running. We're not waiting a week or a week and a half for a new coil or a new system to get scheduled and put in. Put it in and charge it up. And if it works, it works. If it doesn't, it doesn't. But at least you've done something. At least you've tried, right? And then at least the other thing too is now you're experimenting to find out what works and what doesn't, rather than just dismissing and not learning anything in during the time you're experimenting with it.
Well, it's the same thing we talk about when your initial part of the conversation with people dismissing the use of electronic leak detection. We don't want to be dismissive of anything. Now, I know that those in the recovery and evacuation space will contest the fact that the leak sealants and everything else, when you go to put a system under vacuum recover refrigerant, it's an issue pulling those. Like we talk about running a vacuum through a manifold and what that can pull through, and if those properties are in there, pulling that into the manifold itself, that could be a potential issue down the line. So we kind of talked about that in the last podcast a little bit with some of the finer nuances of the recovery process or the evacuation process and vacuum process.
Yeah,
that can be an issue. And again, we're not dismissive. We're even in today's modern world, we want to be all inclusive, but we want to just use the right tool for the right situation. And if it calls for it, and it's the financials call for it, and the timing calls for it, and if that's what you got to use, and that's what you got to use.
I like I said, I mean, it has to be the right scenario. If you leak check the system and there's your electronic hits, you verify it with some bubbles, then guess what? You're going to pull out your torches and fix that leak. You're not gonna try to put sealant in a system. The other thing that I would not recommend you do is you blindly put it in without trying to find the leak first. I wrote an article on this, and it's kind of comprehensive on step by step on before you put a sealant in, and there's like 8-9 steps And then sealant is the very last resort. It's not something you do first, ever, right? It's the very last resort. And maybe I'll try to find that article and put it in the summary of this podcast. So, I mean, what else can we discuss here when it comes to leak checking? One thing I wanted to bring up when you were talking about oil, there's people out there that think if there's a puddle of oil and you put your leak detector in it, it's always going to go off. Well, it's not. Once that refrigerant boils out of that oil, you're not going to have it go off. And I've tested this many times, and because I've got a post on, I think it's Instagram, where I'm pulling a cap off a Schrader, and right away my leak detector's hitting on it because the Schrader's leaking and it's building up inside. And people are going, well, there's the residual oil in the cap. It's always going to go off. Well, not exactly. There's got to be a refrigerant in that oil for it to go off, right?
So especially in coil pans, if obviously you get the residual, condensation at the bottom, one of the things you do is you put your fingers in that liquid to see if there's any viscosity to it, if you can dissect it. So you might be able to see it kind of hazing on the surface of it, but also put your fingers in there and do this and see if there's any oily viscosity to it. Then if there is, chances are it actually obviously leaked down, and you can start searching that coil from there, looking at the tubes and looking at the brazing connections and everything else. But you'll see that sitting down there. There's visual cues. I think a lot of times we just go for the leak, like the electronic or the soap bubbles, without doing an actual visual and tactile perception of what we're dealing with here. We should be using our own senses at our ready as well, instead of just going right for that mechanical, because you might find it quicker.
It's a good point what you're saying, because I've actually seen rooftops puddles underneath the P-trap, and you can see there's oil on top of the water.
Yeah.
So where's that oil coming from? It's got to be coming from a small leak in that coil.
Yeah, exactly. And then you kind of work your way, go up, you know what I mean? These things are going to leave clues a lot of times, and just follow the clues. It's like putting a puzzle together. And then you'll eventually get to that genus point of where those leaks are, and obviously your electronic leak detection, yes. And then soap bubbles, if you really want to make it, obviously get it more precise when it's going to bubble up for you, then you know exactly where to start your repair process.
Cool. All right. Well, listen, you've given us your time and your knowledge here. So I'm going to give you some time to talk about this device right here. This is the SIRD3 leak detector from Sauermann. So maybe run us through this detector, maybe some of its design, its function, refrigerants that it can detect, so on.
In today's wonderful A2L transition world, to R454B, this detector will pick it up, refrigerant leak detection. So it does R1234Y, it does R32. So it does all the different refrigerants. We have to get the spec sheet or data sheet updated for it and the packaging updated for it, but it can detect them as other detectors on the market can. But we can detect it. It is a heated diode system on that one there. Highly effective, highly sensitive. Obviously have your low, medium, and high sensitivities, both visual or LED and audible alerts as well. It comes in at a price point too for a technician, whether you have deep pockets or not. It comes in at a price point that is very, very, very low cost of entry to have a very good electronic leak detector. Because sometimes you hear it's too expensive to get one. It's not. If you can look at that one, obviously you could see the way that the bending of the connection there, getting into those different spots of the wand. Again, there's different spots. It is very flexible, which makes it highly versatile. Again, many others are on the market, very, very similar in that regard as well. So there's no mystery there. That's been templated over the years, but the sensitivity of it is very, very good. And we've had technicians all around the country have had tremendous success with it. And we've even a lot of appliance companies that have bought them, that use them for their appliance business, that will find refrigerant leaks with that. And again, it's one part in your arsenal. But again, cost of entry, very inexpensive. We're not at a race to the bottom, but it's just the cost of entry happens to be inexpensive compared to other things out there. Heated diode, accurate, the whole nine. So it's one tool in your arsenal to go after a leak.
From what I recall, correct me if I'm wrong here, but I thought on high mode, the specs read at 0 to 3 grams
Correct.
per year of refrigerant. Yeah. Yeah. So that's a very sensitive
Yep.
detection. What about like, so it takes 4 AAA batteries.
Yes.
Okay. So the other thing I was going to ask is, what about warranty on it? Because people
So
always want to know that.
2 years.
2 year warranty on it.
Yep. Yep.
Okay, cool. And you brought up 1, 2, 3, 4 Y. I don't even think I've heard of that refrigerant. What are they putting that into?
That is what's blended with R32 to make the R54B.
Oh, okay.
So those two things together. So we're able to detect each of them individually or encompassed together in a blend refrigerant, such as what the A2Ls are, which is R454B.
So I haven't even touched A2L yet. So I haven't even touched A2Ls yet. I haven't seen them. I haven't touched them.
Yeah.
So I haven't gone down that rabbit hole of these mixtures yet. So thank you for clarifying that.
Sure.
I mean, it's crazy that, like, you guys, Sauermann to me has always been like condensate pumps. Now it's combustion analyzers, refrigerant leak detectors,
Right.
probes, manifolds. So
Yeah.
it's kind of cool to see the expansion of the tool collection going on.
Yeah, we've had a lot of corporate investment into this line and into the combustion analyzers, which it's paid off. So you all know, listening, where the combustion analyzers sit, fastest growing line out there for combustion. On the MeasureQuick platform, a preferred analyzer used by the National Comfort Institute here in the States, or even though they're here in the States or a global training organization, they're the best out there. And we're on the company of many great products out there across the board. And this is just another product. So this is our second one here with the new manifold setup that we're coming out with. That'll be on the MeasureQuick platform as well as the analyzer. So that's a nice little shot in the arm for us. That shows a little bit of a job well done. And we have an ethos, designed by techs for techs. And we take input from myself, other technicians from around the country, from around the world. You like yourself, we want, just as an example, from the combustion side, because the manifold just launched yesterday. But from the combustion side, after we launched, you think you have it perfect and you have it as perfect as humans can make it. But then through the use of the app, people say, I have this many photos on the app that I can include in my report. Can you add to that? You know what? Sure, we can. So let's go back and take a look at that. Or we can double the speed of this CO sensor. We could double the speed of the refresh rate of the screen when we're reading. So there's all these different things that we can do to improve the tool. We like to listen to those that are using it. So we like to pay attention to the needs and wants of our end users, and then design tools and reverse engineer it and design things for them to be as effective as possible. And we've made some nice headway here, where some people have said we're a household name. If not, we're becoming one from the instrumentation standpoint. We're in a space with many excellent competitors and great companies. There's a lot of great companies out there. Success leaves clues. We're picking up the clues, and we're modifying our own approach out there, and adding some features that we talked about before, like with the manifold, the ER, the efficiency, the diagnostic mode, which I don't think we talked about last time. There's a diagnostic mode in there. So if you're a newer tech, it runs you through a series of questions to get you through. It's like a funneling effect where you start up here and it narrows itself down, and you can actually get to what chances are would be the appropriate repair or the appropriate thing that's wrong with that system. And then you know what to attack from there. MeasureQuick takes that and puts that on multiple cycles of steroids for an approach. I mean, MeasureQuick is the best diagnostic aid out there, in my opinion, for anything like this, whether it's commissioning, diagnostics, or just general maintenance. But this manifold, given the size of it, its footprint and the way that the probes act, and the speed and accuracy of everything, and the proper, thermistor, clamp and everything else, and temperature clamps that we have, we think we're going to make some nice headway in the industry with this, and judged by the pre-orders, that seems to be the echoing effect.
Awesome. All right, man. Well, thank you once again for this. Is going to be a two-parter because we talked for almost an hour here. So, audience, you're going to get hit 4 times in a row by Pilot Nelson. So I hope you appreciate him and the knowledge and the conversation that we brought to you guys today. So, Tyler, thank you very much, man.
Thank you, Gary. I greatly appreciate it.